Hi, I'm Gregory Massa, and today we're going to be focusing on Module 2. More specifically, we're going to be looking at naming organic compounds with multiple functional groups. We're going to start off by looking at how we name functional groups when they are the priority in the compound. Then we're going to be looking at how to name functional groups when they are the substituent in the compound. We're then going to practice naming organic compounds with multiple functional groups with 3 different examples. And then finally, we're going to look at the application of organic compounds and seeing how organic compounds appear in our everyday life. As I mentioned, we're first going to look at how to name functional groups when they are the priority. This was covered in the lecture material, so I'll only briefly go over this. Some of the groups I want to focus on are carboxylic acids. So a carboxylic acid is where we're going to have an oxygen double bonded to a carbon, and that same carbon is also going to be bonded to an alcohol. It's almost as if an aldehyde and an alcohol came together. I also want to focus on an amide. So an amide is where we're going to have an oxygen double bonded to a carbon, but instead of having an alcohol bonded to that same carbon like we do in a carboxylic acid, we're instead going to have an NH2 bonded to that carbon. Finally, I want to go over the difference between aldehydes and ketones. So an aldehyde is where an oxygen is going to be double bonded to a carbon, and that's going to be at the end of the chain. Whereas in ketones, the oxygen double bonded to the carbon is going to be in the middle of the chain. We know that this is at the start and the middle of the chain by the diagram because the R represents the continuation of the carbon chain in that direction. So with the aldehyde, in this picture here, we see that the carbon chain is going to be continued in the left direction, however not in the right direction. Whereas when we look at the ketone, it's going to be continued in both directions. Next, we're going to be looking at rules for naming groups as substituents. So a group is named as a substituent when it is not the priority functional group in that compound. Some of the ones I want to focus on are when a ketone is not the priority functional group, it's going to be called oxo. When an alcohol is not the priority functional group, it's going to be called hydroxy. And when an amine is not the priority functional group, it's going to be called amino. These are going to be important as these are 3 of the substituents that I focus on when we start practicing naming organic compounds with multiple functional groups. One functional group that was not covered in the last diagram is benzene. So benzene is a substituent when it is not the priority functional group and when the carbon chain that it is attached to is greater than 6 carbons long. In this case, when benzene is the substituent, we call it phenyl. Now we are going to begin practice naming organic compounds with multiple functional groups. My strategy for naming organic compounds with multiple functional groups is to first count each of the carbons in the compound and then to name the functional groups in this compound. So we have 1, 2, 3, 4, 5 carbons. And now we can start naming the functional groups. So for the priority functional group, we're going to have an amide. Now we know this is an amide because we have a carbon double bonded to an oxygen, and that same carbon is bonded to an NH2. We also have a substituent of an alcohol. And we know this is an alcohol because we have a carbon bonded to an OH. With this information, we know to name this compound 3-hydroxypentaneamide. And the pentane comes from the fact that we have 5 carbons. We're going to practice naming organic compounds with multiple functional groups with a second example. Once again, we're going to start off by numbering the carbons. So we have 1, 2, 3, 4, 5. Same as the last one. And now we're going to start naming the functional groups. So this is our priority functional group. We have a carboxylic acid. And as our substituents, we have a chlorine. And we have an alcohol. With this information, we know to name this compound 3-chloro-4-hydroxypentaenoic acid. We're going to do one last practice question to help us with naming organic compounds with multiple functional groups. As always, we're going to start off by numbering the carbons. So we have 1, 2, 3, 4, 5, 6, 7 carbons. And now we're going to label the functional groups. Our priority functional groups is an aldehyde. And our substituents are a bromine, a chlorine, and an alcohol. With this information, we know to name this compound 3-bromo, 4-chloro, 5-hydroxyheptanol. we're going to be moving on to the final part of this presentation, and that is the application of organic molecules and how they appear in our everyday lives. The first organic molecule we're going to be looking at is pyruvate. Now, for those of you who haven't taken the BIOL 102 course or are not familiar with it, pyruvate is essential in cellular respiration. It is made in glycolysis, where one glucose molecule becomes two pyruvate molecules. And then in the pyruvate oxidation, one pyruvate molecule becomes one acetyl-CoA molecule. Now, acetyl-CoA is used in the citric acid cycle, and this cycle leads to the electron transport chain, where we generate ATP. And ATP is where we get our energy from. So this is a very important molecule. Now, we're going to be looking at the organic structure of pyruvate. We're going to be looking at the functional groups that are contained in pyruvate. So the first one is a ketone. That's pretty simple. We've gone over this quite a bit of times, as well as in the lecture content. However, the second one is unfamiliar to us. It is our carboxylate. So a carboxylate is a conjugate base of a carboxylic acid. So that'd be right here. Now, this would be a carboxylic acid if we weren't missing the H. However, we are missing the H, which makes this a carboxylate. The next organic molecule that we're going to be looking at that appears in our everyday lives is aspirin. Aspirin is a painkiller that can be found in almost any pharmacy. It is used to treat headaches, cramps, colds, and flus. However, in order to take aspirin, it is recommended that you are at least 16 years of age. As we did with pyruvate, we're now going to be looking at the organic structure of aspirin by looking at which functional groups are contained in the compound. The first functional group is a carboxylic acid, which is located right here. The next one is a benzene. And finally, we have an ester, located right here. The third and final organic compound that we're going to be looking at that appears in our everyday life is glucose. Now, glucose is the most abundant monosaccharide, and it is a carbohydrate. As I mentioned before, glucose is consumed in cellular respiration. However, it is produced in photosynthesis. In cellular respiration, the first step is glycolysis, where glucose is converted into two pyruvate molecules. However, in photosynthesis, glucose is one of the products. Now, photosynthesis is often referred to as the reverse of cellular respiration, and plants perform photosynthesis in order to make their own glucose so they can use it in cellular respiration, as plants can perform both photosynthesis and cellular respiration, while animals can only perform cellular respiration. Now, glucose is found in carbohydrates, proteins, and fats. So all of these different pictures that you see on the screen here all contain glucose. When looking at the structure of glucose, we can see that it contains two different functional groups. The first one is an aldehyde, and the second one is alcohols. Now it contains many different alcohols. We have one here, a second here, a third, a fourth, and a fifth. So glucose contains 5 separate alcohols. To summarize what we have gone over today, we started off by looking at how to name functional groups when they are the priority, as well as how to name functional groups when they are the substituent, meaning when that functional group is not the priority. We then practiced naming organic compounds with multiple functional groups, and using the methods of numbering each carbon in the chain, as well as the circling method, helped us stay organized. They also helped us see how long the carbon chain was, and finally, it helped us easily identify which functional groups were contained in that compound. Finally, we looked at everyday examples of organic compounds. We first looked at pyruvate, then aspirin, and finally, we looked at glucose. After that, we were able to identify the functional groups in each of these compounds. These are my references. Thank you very much for listening.